location on the beach, the mission specialists will anchor the flexible pipe to the beach. The first ashore lines will be disconnected from the pulling head and recovered by the OPDS ship. Once the lines have been recovered, the OPDS ship will deploy the remainder of the flexible pipe. From this point, it can take up to 36 hours to complete the pipe deployment and hook up to the tanker and be ready to pump. The LARC method is considered a secondary method to beach the flexible pipe. It is typically done when low current and steep beach gradient exist. The steep gradient allows the OPDS ship to get close to the beach. In a typical LARC method deployment, the OPDS ship will likely be less than 3,000 feet from the beach. The OPDS ship will dynamically position itself directly off the beach from the proposed BTU site in approximately 30 feet of water. Once the OPDS ship is stationary, a single LARC is launched and 2 LARC winch lines are passed from the LARC to the OPDS ship and connected to the pulling head on the first section of flexible pipe. As the LARC heads toward the beach, the LARC crew will pay out both winch lines. Once the LARC reaches the BTU site, the mission specialists will anchor the LARC to the beach using the excavator to set the helical anchors. Once the LARC is anchored, the flexible pipe can be pulled to the beach with the 2 LARC winch capstans. Once the flexible pipe reaches the beach, the LARC crew will anchor the flexible pipe to the beach and the ship can deploy the remaining flexible pipe. The third method of flexible pipe deployment is the dozer pull method. This method is normally used when the ship is more than 9,000 feet from the beach and requires 2 D7 or larger type bulldozers with at least 25 tons of pull. One dozer will pull while the other will function as a dead man to attach a snatch block to allow the pulling dozer to pull parallel to the beach. This method requires a minimum of 1,000 feet of space on the beach to allow the dozers to operate. Once the dozer pulls the flexible pipe to the high water mark, the LARC crew will anchor the flexible pipe to the beach and the ship can deploy the remaining flexible pipe. Regardless of which deployment method is used, once the flexible pipe is anchored to the beach, the BTU will be installed, all lines will be recovered, and the remainder of the flexible pipe will be deployed by the OPDS ship. While deploying the pipe, the OPDS ship will move along the deployment route at a speed not to exceed 1.5 knots. At this point, the flexible pipe will not have float buoys attached, so the flexible pipe will go directly to the ocean bottom. The ship will stop when each reel is depleted to allow a connection of the next flexible pipe or risers for a given deployment. This connection normally takes about 2 hours to accomplish. Once the entire flexible pipe, including the riser, is deployed, a flotation collar and quick connect-disconnect coupling, or QC-DC, is installed on the seaward end of the flexible pipe and is overboarded and will be tended by one of the ship's 12-meter workboats. The flotation collar allows the seaward end of the flexible pipe to float at the surface while being tended so Wheeler can rendezvous with the tanker or water barge and take it in tow and subsequently connect to the bow discharge system. Once in tow, the OPDS ship will maneuver back to the location of the flotation collar and using the bow discharge unit winches, will raise and connect the QC-DC to the BDU. If a barge or tanker were small enough, they could moor alongside Wheeler with large fenders between the vessels rather than use the towing winch. However, rough or choppy seas may not permit the vessels to remain alongside. Upon completion of the BDU connection, a 950-foot float hose will be connected from the stern of the OPDS ship to the tanker or barge. Once all connections have been made and the military unit receiving the fuel is ready, the tanker will pump into the OPDS ship's buffer tanks and the ship's high-pressure pumps can then pump the product to the beach. Once the OPDS has completed her pumping mission, the flexible pipe will be cleared of all remaining product using a foam pig that is inserted into the flow path and pushed through the flexible pipe using the ship's onboard nitrogen generator. Once the line has been completely pigged and the BTU disconnected from the user's services, the system can be recovered within 72 hours and be ready again to meet the needs of combatant commanders around the world. The Wheeler is also a multi-purpose vessel with a towing winch that can tow a large tanker or cargo ship in distress, and fire monitors for assisting in firefighting efforts afloat and ashore as needed. Additionally, the Wheeler can support humanitarian assistance and disaster relief efforts by supplying potable water, electricity, or deliver supplies. OPDS is essential to our nation's military needs and provides a critical system to pump large quantities of fuel ashore in austere environments. OPDS is flexible and can react quickly to assist in fighting and winning our nation's wars. OPDS fulfills the needs of our combatant commanders and their units in the field.
The Wheeler is a strategic asset and a one-of-a-kind vessel with a vital mission to put large quantities of fuel on the beach from 8 miles offshore in support of ground forces maneuvering. Without this capability, supplying fuel to our ground forces would be very difficult and a time-consuming task.
The mission of the Wheeler is to establish a beachhead in an isolated area and lay 8 miles of high-pressure pipe and pump 1.7 million gallons of fuel in a 20-hour day.
Can pump over 1,400 gallons a minute. There's no other vessel like it in the world. No other vessel that has the same capability Wheeler does.